Number 1, 4 times the quantity 5 plus I square root of 5. Basically what you'll want to do, anytime you've got a number outside of a parentheses butted up against the parentheses, you'll distribute it. 4 times 5, pretty straightforward, 20. And then 4 times I square root of 5. Since the 4 is not a radical, it's not a square root, we'll just tack it on to the outside. So we'll make this 4I square root of 5. And since those are not like terms, we can't put them together. Well, another way you could also write this, I'm not exactly sure how the computer is going to want you to enter this, but you could put 4 square root of 5 as long as you've got I out to the right. So not underneath the radical, but just out to the right. It should take either one of those versions. Number 2, negative 3I times the quantity 5 minus I square root of 11. Distributing just like on number 1, negative 3I times 5. You're going to multiply those numbers, negative 15I. Then doing the second distribution, negative 3I times negative I square root of 11. That's going to be positive since you've got a negative times a negative. And you've got 3I squared, I times I, and then tack that square root of 11 on there. Again, not multiplying the 3 and the 11 because the 3 is not a square root. If you've got a square root times a square root, you'll actually multiply those numbers underneath. But here we're not doing that. Another thing that you'll want to remember, anytime we see I squared, you're always going to replace I squared with negative 1. Always replace I squared with negative 1. So what we've got on the next step is negative 15I plus 3. And since it's times I squared, we're going to multiply negative 1 and then square root of 11. So we end up with negative 15I. 3 times negative 1 is negative 3. Square root of 11. And lastly, I mentioned this on a previous lesson. You're going to put the I term second. So this is technically all we're going to end up with, but put the I term second. And make sure as you shuffle things around, your signs stay the same. The 3 is still negative when you move it out front. The 15I is still negative when you move it to the end. Number 3, negative 2 minus 8I times negative 5 plus 3I. Anytime you've got a binomial, which is this first parentheses, times another binomial, second parentheses, you're going to FOIL or double distribution is another way of looking at it. You're going to distribute the negative 2. Also, after that, you're going to distribute negative 8I. So we'll go ahead and go through that. Negative 2 times negative 5 is positive 10. Negative 2 times 3I is negative 6I. Then moving on to the negative 8I. Negative 8I times negative 5 is positive 40I. And then negative 8I times positive 3I is going to be negative 24. And since we're multiplying two i's there, that's going to be I squared. And then keep in mind, I squared, we're always going to replace with negative 1. So moving down, 10, these two terms in the middle are like terms. Negative 6i, positive 40i is going to be positive 34i. And then we've got negative 24 times negative 1. The 24 was multiplying times the I squared, so make sure you multiply the negative 1 instead of just subtracting it. And that's going to be positive 24. So we've got 10 plus 34i plus 24, and then you can put your like terms together. The 10 and the 24 make 34, and then you've got the 34i. Be careful you don't replace the I with negative 1. We only do the replacing when it's I squared. Number 4, 7 minus 7i times 7 plus 7i. We're going to FOIL again. So 7 times 7, 49. 7 times 7i, it's going to be 49i. In the middle, negative 7i times 7, it's going to be negative 49i. And then lastly, negative 7i times positive 7i. Negative times a positive is negative. 7 and 7 is 49. And then your i's that you're multiplying give you I squared. So a couple things after that, you'll be able to put the I terms together. They're like terms. And then also remember that I squared is negative 1. So we got 49 plus 90. Ooh. The two middle terms in the with the i's, the 49i, the negative 49i, those two cancel each other out. And we're left with negative 49 on the end times negative 1. So 49 plus 49, negative 49 times negative 1, positive 49, and then we just add those. Number 5, 6 plus 2i squared. Not a whole lot that's different on this one, except you'll want to write out 6 plus 2i, and then since we're squaring it, we're taking it times itself. Another 6 plus 2i. And then from there, just like the previous ones, we're just going to FOIL. Distribute the 6. Distribute the 2i. 6 times 6. 6 times 2i. In the middle, 2i times 6. And then lastly, 2i times 2i is positive 4. And then since we're multiplying i's, we've got I squared. You have a few of these where the two middle terms will cancel, but you want to be careful on this one. These two don't cancel. They're both positive, so positive 12 ends up with 24 and I. So 36, positive 24i, and then hopefully you can do this in your head. 4 times negative 1 is going to be negative 4. Put your like terms together. We've got 32 plus 24i, and as long as your I term is second, that's good to go. Number 6, 4 minus I squared root of 5 times 4 plus I squared root of 5. And one thing before we do another one like this, you might notice that these binomials look almost identical. The only difference is the sign that you've got between them. Here we've got a negative in the middle. Here we've got a positive in the middle. Anytime you FOIL with these, which we would do, anytime you do that, the outers and the inners will cancel. So we'll go ahead and go through this and take the 4 times the 4, 4 times that. So first times first, outers, inners, and then the last ones in both those parentheses. So 4 times 4 would give us 16. 4 times positive I squared root of 5. Again, you're not going to multiply the 4 and the 5. You're just going to butt them all up against each other. So this will be positive 4i square root of 5. Moving on to the middle, negative I square root of 5 times 4 is going to be negative 4i square root of 5. And then lastly, the negative I squared root of 5 times the positive I squared root of 5. Positive times negative is negative. Got I times I, which is I squared. And since we're multiplying square root of 5 and then another square root of 5, here we're going to multiply those numbers to get the square root of 25. And then a couple things there. Like I said before, when you multiply, these are called conjugates. We'll talk about that just a bit more on an example coming up. But the two middle terms will cancel. 4i squared root of 5 and negative 4i squared root of 5. Those are gone. Here we've got negative 1. So we've got a minus in front of negative 1. And then also the square root of 25. Hopefully everyone knows square root of 25 is just 5. So we've got the 16 out front. Bring all that together. We've got 16. This minus minus here, that just turns into a plus. So we've got plus 1 times 5, which is just 5. And then ultimately we end up with 21. Number 7, square root of 6 minus 5i times square root of 6 plus 8i. These ones aren't conjugates, though. They start out the same way, but they're not identical. So square root of 6 times square root of 6 would be square root of 36. Square root of 6 times 8i. Then in the middle, negative 5i times square root of 6 is going to be negative 5i square root of 6, just butting them up against each other. And then lastly, negative 5i times positive 8i. It's going to be negative 40 and then I squared. So a couple things here. We've got square root of 6's that we can put both those terms together. Just going to put the numbers in front together. On the end here, we've got that negative 1, and then square root of 36, maybe you know, is 6. Okay, so if we're going to put the two middle terms together, we need to put the 8i and the negative 5i together. That's actually going to give us 3i. And then the square root of 6 part does not change. Just putting the front parts together, the coefficients together. And then you've got negative 40 times negative 1. It's going to be positive 40. And then add your like terms there, the 6 and the 40. Okay, so I mentioned conjugates before, and just to give you a few more examples of those, conjugates are exactly the same, only the sign in the middle is different. So got x plus 5, x minus 5 if you had negative, square root of 7 plus 2. Conjugate of that, again, exactly the same, only the sign in the middle is different. If you had 5i plus 4, well, let's say minus 4. Conjugate of that, 5i plus 4. So conjugates are going to be important because on the next couple examples, we'll have an I term on bottom. If you've got an I term on bottom, what we'll do is we'll do some work to get rid of the I on bottom, and we'll multiply conjugates if there's an I on bottom. There's an I in the denominator. Multiply conjugates. Number 8, here we've got an I on bottom. We've got 4 plus 6i on top, 8 plus 3i on bottom. So if we've got an I on bottom, we're going to multiply the conjugate. And on bottom, that would be 8 minus 3i. We're multiplying the conjugate of the bottom on the bottom and also the top. So here we'll duplicate that. And then you're just doing FOIL on top and bottom. Basically, we've got a situation like that. Two parentheses being multiplied. The bottom are conjugates, 8 plus 3i, 8 minus 3i, so it might save you a little bit of time if you just skip the O and the I. On the bottom, we'll only need to do the 8 times the 8 and the 3i times the negative 3i. That's the first times the first, and then the last times the last. On top, though, we'll need to do the normal distribution, 4 times all that, and then the 6 times all that. So go ahead and do the top. 4 times 8. 4 times negative 3i. Then moving on to the 6i. 6i times 8. 6i times negative 3i is going to be negative 18i squared. So we'll simplify that here in just a minute. On the bottom, though, we've got 8 times 8, which is 64. And we're going to skip the O and the I and just do the 3i times negative 3i. That's going to be negative 9i squared. Got some like terms we can put together. We also have an I squared that we'll replace with negative 1. Also on the bottom. So we've got 32 plus 36i. And then negative 18 times negative 1 is going to be positive 18. On bottom, 64, and then negative 9 times negative 1 is going to be positive 9. Like terms on top and bottom. $50 plus 36i over 73, or they may want you to split all this up where you do something like 50 over 73 plus 36 over 73i. Number 9, 4 plus 5i over negative 5 plus 3i. Here we've got an I on the bottom again. So when that happens, we're going to multiply the conjugate. And we're only going to use the conjugate of the bottom. So the conjugate of the bottom will be negative 5 minus 3i. Same thing on top. Again, going to FOIL on the top and bottom. And since the bottom ones are conjugates, we can skip the O and the I. So 4 times negative 5, doing the top first, negative 20. 4 times negative 3i, negative 12i. Then moving on to the 5i next. 5i times negative 5 is negative 25i. And then 5i times negative 3i, negative 15i squared. On the bottom, negative 5 times negative 5. And then 3i times negative 3i is going to be negative 9i squared. Some I squareds there to consider, some like terms in the middle to consider. So negative 5 minus 37i over 34. So the software may want it like that, or it may want you to split it up. Negative 5 over 34 minus 37 over 34 with an I out to the side. So for the last couple examples, there's two things about I that you'll want to keep in mind. The most important is I squared. Anytime you see that, you're going to replace that with negative 1. Always replace I squared with negative 1. Also, any multiple, well, any exponent that's a multiple of 4. Is 1. Any multiple of 4 exponent is 1. So what I mean by that is I to the 4th would be equal to 1. Any multiple of 4. So multiples of 4 would be 4, 8, 12, 16, and then so on. So if we had I to the 8th, that would also be 1. If we had I to the 20th, 20 is a multiple of 4. That would also be 1. I to the 40th That'd also be 1. It might help to make a list of, a longer list of multiples of 4. If you're not sure just by looking at it, whether it's a multiple of 4. 20, 24, 28, 32, 36, 40, and you can go on from there. But I to any of these powers is going to be equal to 1. So those are 2 things that are to remember that'll come in handy on the next 2 examples. Number 10 should be pretty easy. I to the 8th, it's a multiple of 4. So the whole thing just equals 1. I to the 20th, what you'll want to do, since it's not I squared, which we replace with -1, it's not a multiple of 4. But the largest, and we want to look at the largest multiple of 4 that's in it, would be 20. The largest multiple of 4 in 21 is 20. So what we can do is we can rewrite this as I to the 20th times I to the 1st. And that's just derived from that. I to the 20th times I to the 1st is I to the 21st. But this I to the 20th part, we know is 1. So if you replace I to the 20th with 1, I to the 1st, we don't know what that is. That just stays as 1. So we basically got 1, or that just stays as I. 1 times I equals 1I, or just I. One bonus example, if you got I to the 23rd, again, you'll still want to notice that it's not a multiple of 4 and that the largest multiple of 4 in it is still 20. So what you would need to do is rewrite this as I to the 20th times I to the 3rd. Still comes out to the 23, but this I to the 20th we can replace with 1. 1 times I to the 3rd is just I to the 3rd. And you might be tempted to stop there, but we can rewrite I to the 3rd with another thing that we know, which is I squared. We can write I to the 3rd as I squared times I to the 1st. The exponent should add to be the 3. And maybe you remember I squared is the same as -1. -1 times I is just -I.